The question says a hydrocarbon C5H10 does not react with chlorine in dark but gives a single monochloro compound C5H9Cl in bright sunlight. Keep in mind, reaction is taking place in the presence of sunlight, means reaction takes place via free radical mechanism. Okay, via free radical mechanism. And question says identify the hydrocarbon. What kind of hydrocarbon we have? Saturated hydrocarbon, unsaturated hydrocarbon, yeah, cyclic compound is there. To identify the type of the compound, we can first of all calculate the degree of unsaturation. The formula we have degree of unsaturation, degree of unsaturation is there. So the formula we have 2 carbon plus 2 and then we have minus hydrogen divided by 2. Okay, so we have the compound C5H10 is there. So how many carbon are there? There are 5 carbons. We can plug in here 2 multiplied by 5 plus 2 and then minus how many hydrogen are there? 10 hydrogen is there. Plug in here and divided by 2. If you simplify, this is 5 to 10 and 10 will cancel out. 2 by 2 is equal to 1. So degree of unsaturation we get 1. Okay, and if degree of unsaturation is 1, so in this case double bond is possible. Yeah, it can be one cyclic ring is also possible, cyclic. Okay, so we can try one by one. First I take a compound having double bond and carry out halogenation. Okay, that is chlorination, and then we can take the cyclic compound and we see in which case we can get the single monochloro compound. First I take double bond. Anyway, if you look at the compound C5H10 is there. Okay, we have C5H10 is there, and this compound is given in terms of general formula CnH2n is there, where n is equal to 5, and this is what alkene exactly. This is the general formula of alkene, means one double bond is there. So now let's say how many carbon are there? 5 carbon are there. 5 carbon. So there are two cases where we can keep the double bond. If I keep the double bond here, so it will be pent 1 in. If I keep double bond here, it will be pent 2 in. And if I keep double bond here, again we'll get pent 2 in, because we will start numbering from this side, pent 2 in. Okay, so 2 places are there if I am keeping the double bond. Let's say I keep double bond here. Okay, pent 1 is possible, pent 2 in is also possible. Okay, in the straight chain. And we have Cl2 reaction is taking place in the presence of sunlight. Okay, now if you want to satisfy the valency CH3, it is H2 is there, it is H2, and we have H and it is CH2 is there. Okay, reaction is taking place via free radical mechanisms. Free radicals we have to generate. So you can see Cl2 is there, so you can see we can have equal distribution of the electron. So here we get Cl dot, here also Cl dot is there. So we got Cl dot and Cl dot is there. Okay, here also pi bond, you can see pi bond is there, and so pi electrons are equally distributed. So one dot will go here and one dot will go here. Okay, so Cl will connect to this carbon and this Cl will connect to this carbon. So as a result, the product which we are supposed to get, this is CH3, CH2, CH2, and then we get CHCl, and this is CH2, Cl is there. Okay, so now you can see when we do the halogenation of alkene having double bond in the presence of sunlight, we are getting dichloropentane. And question says the product must be formed a single monochloro derivatives. Okay, only one Cl should attach to the carbon chain. Here we are getting 2 Cl. Okay, we can say this is 1,2-dichloropentane. We are getting dichloro. Means the compound should not have double bond. Okay, compound, then we can go for the cyclic. Even if I keep the double bond here in this place, so again Cl will attach here, one Cl will attach here, one Cl will attach here, again we'll get the dichloro compound. Means definitely it is not alkene. Now we go back. Now you can see double bond part we have tried already, double bond. So double bond is not possible. If double bond is present, we are getting dichloro. Then we can go for the cyclic. Okay, so in case of cyclic, you can see in C5H10 how many carbon are there? 5 carbon are there. So I can form a 5-membered cyclic ring. We have 5-membered cyclic ring. So let's say it is a CH2, then CH2, and this is CH2, and here we got CH2. Total 4 carbon, 5 carbon, CH2 is there. Okay, 5 carbon. So you can see 5 carbon and 10 hydrogen because each carbon has 2 hydrogen. Okay, so chemical formula we got C5H10 is there. This is the structure, cyclopentane. And you can see in this compound each carbon is in the same environment. Each carbon is having 2 hydrogen. Okay, now if this substance is undergoing halogenation, Cl2H2 is there, free radical mechanism, you can see Cl and Cl is there, equal distribution of electron will be there, Cl dot and Cl dot is there. Very interesting question. Okay, here also any of the you can see carbon hydrogen bond you can consider because each carbon hydrogen bond is same only. Okay, so let's say I have this hydrogen is there, this hydrogen. So here we can mention this is what hydrogen is there, so equal distribution of electron. Okay, keep in mind in free radical generation, you know, we do not consider electronegativity difference. You cannot say carbon is more electronegative than hydrogen, then it is pulling electron density, because this reaction is taking place via free radical mechanism irrespective of electronegativity. Okay, so here we get CH dot and here we got H dot is there. So you can see CH dot and Cl dot will connect to one Cl will come here, and this H dot and Cl dot will connect, this HCl will be separated. So we got we can write this compound in this format also. You can see here we got the Cl and this is what HCl is there. You can see only one Cl is getting connected. Okay, only one Cl is connected. We got single monochloro. You can attach Cl to any of these carbon, will get one. We can see, you can see chloro, we have chloro, cyclopentane is there. Anywhere you can attach Cl, but only one Cl will attach because another Cl will go with hydrogen. Okay, so we can say identify the hydrocarbon. What is the hydrocarbon? We have cyclopentane. C5H10 is nothing but cyclopentane. Keep in mind this reaction does not take place in the absence of sunlight. It takes place only in the presence of sunlight. Free radical mechanism, a free radical reaction take place only in the presence of sunlight. If you like this video, please share and subscribe to the channel.